Military training installations face increasing wildfire risks, a reality that necessitates effective and advanced training. Without modern tools, planning, mitigation, and response are hindered, leading to inadequate preparedness and increased danger for our personnel. Terasynth's solution is the FAST, Fire Analysis and Simulation Toolkit, a scalable, standalone VR-compatible tool that realistically models fire behavior in an immersive, interactive environment. We've designed FAST to provide intuitive, multi-angle visualization, enabling a significant increase in data value for a broad audience and enhancing both training safety and operational understanding. Welcome to the Terasynth FAST UI. This is our full-screen, map-based application. In the top right, you'll see the width and height of our current view in kilometers, giving us a clear sense of scale. Let's navigate to Olympic National Park in Washington to begin our demonstration. On the right, you'll find our control panel. Let's begin by setting up a scenario with the ignition control panel. We'll place a large point ignition source, represented by this scalable circle, directly on the map. Next, we'll open the fuel analysis panel. Here, we could manually draw polygons to define different fuel types. But for this demonstration, we'll use our Predict with AI button to quickly analyze the region. Our AI, leveraging GPS, real-time weather, and a visual analysis of the satellite imagery, instantly generates a rough but highly plausible fuel prediction for the entire area. The fuel polygons are now generated. We can click any polygon to edit its parameters, including fuel height, loading, moisture, density, and surface area volume. You can see how more flammable fuel is represented by a deeper green, while less flammable fuel is yellow. Now, let's open the meteorology panel. While these settings can be manually adjusted, every time the map is panned, they automatically update to reflect the actual real-time weather for that region, grounding our simulations in reality. The application offers multiple map views, including satellite, map, and a map with a terrain bevel, to provide comprehensive context. With our scenario set, let's click Run Simulation. The simulation is running. The orange polygon represents the active leading edge of the fire, while the brownish area is the burn scar, the total area already consumed. Once the simulation completes, we are presented with the simulation results. The panel on the right, below the timeline slider, displays our detailed results. The Overview tab gives us a high-level summary. Here, we can see the total burned area in both square kilometers and acres, and track the total mass burnt over time with a line graph. Crucially, the Key Events timeline provides an AI-generated analysis of significant moments, explaining why the fire behaved the way it did at critical junctures. The Emissions tab focuses on environmental impact, with line charts tracking the release of carbon monoxide and PM2.5 over time. The Behavior tab details the physical intensity of the fire, offering toggles to switch between the fire perimeter and a reaction rate heat map, which shows the most intense parts of the fire. When our analysis is complete, we can easily export the results. The download icon opens a menu with 4 options for capturing high-resolution PNG images. We can export the final fire spread for reports, the reaction rate heat map for visualizing intensity, the fuel's post-sim to show how the fire interacted with different vegetation, and the fuel's pre-sim to document the starting conditions. This capability provides a substantial increase in data value and interpretability for a broad audience. For developers and researchers, the View JSON button with its code bracket icon opens a modal with the full simulation data for Unreal Engine. This contains both the inputs and the outputs, including the entire simulation timeline and the AI's key events analysis. This is the raw data that is automatically derived from the FAST UI and visualized in our immersive virtual reality environment in FAST XR. This streamlined process demonstrates a one-touch startup with no steps to engage, ensuring real-world field usability. FAST XR. This is the FAST XR visualization platform, which is fully usable with standalone untethered XR hardware. The exceptional visual fidelity clearly demonstrates complex fire behaviors, differentiating between surface fires, passive and active crown fires, and transitional fire behaviors, both horizontally and vertically. We can also explore the fire environment by manipulating wind speed and direction, and the fire reacts in real time. The platform supports comprehensive and intuitive multi-angle visualization. We can instantly shift from a first-person perspective on the ground to an oblique third-person view or even a god's eye view to get a strategic overview of the entire area. These freely adjustable perspectives provide comprehensive situational awareness and are perfect for training. All of this is done on the standalone headset with no cloud dependency and with advanced cybersecurity protocols in place to protect the integrity of the data and the user. By combining intuitive scenario building with scientifically rigorous modeling and high-fidelity immersive visualization, Terasynth's FAST has a high potential for supporting the development of relevant ignition scenario training with little need for adjustment. This is not just a tool, it's a new paradigm for fire management, empowering those who protect our lands and our people.